The dawn of November 24, 1944, broke over Isley Field on Saipan in the Mariana Islands. Lieutenant Colonel Robert K. Morgan gripped the controls of his B-29 Superfortress, an aircraft bearing the name Dauntless Dottie across its nose. Behind him stretched an armada, 110 silver bombers of the 73rd Bomb Wing, their wings glinting in the morning light as they gathered for the flight to Tokyo. Morgan eased the throttles forward, feeling the massive engines respond with a deep thrumming roar that seemed to shake the very air. The instruments spread across his panel told a story that Japan's military leaders had refused to accept. Beneath his hands, the turbo-supercharger boost gauges climbed with mechanical precision, their needles rising steadily. What they measured was extraordinary. At altitudes where Japanese fighter engines would gasp and wheeze, these machines maintained sea-level power output. The technological advantage these American bombers possessed was absolute, and nothing Japan had in the sky could match it. Today's mission would prove something profound. Tucked deep within each of the B-29's four massive Wright R3350 engines sat a pair of General Electric turbo superchargers, compact devices that looked almost unimportant, yet they were more strategically significant than any gun or bomb carried in the fuselage. These mechanisms worked through elegant simplicity. They captured the enormous heat and pressure of exhaust gases that would otherwise vanish uselessly into the atmosphere. These exhaust gases spun turbine wheels at speeds exceeding 20,000 revolutions per minute, and those turbines drove centrifugal compressors that forced outside air into the engine's intake manifolds at pressures equivalent to sea level, even when the bomber climbed to 32,000 feet, where the air was thin and cold and lifeless. This meant each R3350 engine could produce a steady 2,200 horsepower at altitudes where Japanese fighter engines had already surrendered. The contrast could not have been sharper. Japanese interceptors, designed for the dogfighting battles of earlier years, excelled at medium altitudes where maneuverability meant everything. But at 30,000 feet, their engines gasped and faltered. Their high-altitude supercharging was crude and ineffective. Power plummeted, climb rates became embarrassingly slow, maneuvering became nearly impossible. From the newly captured airfields in the Mariana Islands, this first coordinated B-29 assault on Tokyo represented something fundamentally different from the earlier bombing campaigns. These islands lay only 1,500 miles from Japan's capital. Unlike the grueling missions launched months earlier from distant bases in China, requiring fuel-consuming detours and punishing distances, bombers departing from Saipan could strike Tokyo regularly and still return home safely. The pressurized cabins aboard each Superfortress meant the American crews breathed comfortably at altitude, while Japanese pilots battled hypoxia and cold. As Morgan's bomber lifted into the morning sky, its landing gear retracting with a hydraulic whine, followed by over 100 others, the technological gulf between American and Japanese aviation became impossible to deny. The road to this moment had begun 5 months earlier. On June 15, 1944, the first strategic bombing mission against Japan using B-29s had launched from Chengdu in China. 75 Superfortresses took to the skies that evening, their crews nervous and uncertain, pushing their machines toward the industrial city of Yawata on the island of Kyushu. Yet only 47 managed to locate and bomb the primary target. The mission's cost was severe. 7 aircraft perished. 1 fell to fighter attack directly over the target, burning as it spiraled downward. 1 crashed on the ground after an emergency landing, its structure too damaged to survive. 5 more were lost to operational accidents, mechanical failures, navigation errors, crew mistakes. In total, 57 young American airmen died that day, their names added to the growing roster of sacrifice. Yet even this costly introduction revealed something critical. Japanese air defenses, formidable as they seemed on paper, were inadequate against bombers flying at extreme altitude. On the ground near Yawata, radar operators had detected the approaching formations. Air raid sirens had wailed across the industrial landscape. Pilots of the Imperial Army's 4th Sentai had scrambled toward their cockpits, climbing urgently skyward in their Kawasaki Ki-45 Toryu twin-engine fighters. The Japanese pilots drove their machines upward aggressively, targeting the American bombers that flew between 8,000 and 21,000 feet. Even at these relatively modest heights, dictated by fuel constraints on the exhausting journey from China, the Japanese interceptors struggled visibly. Their engines, Nakajima Ha-25 designs, rated at merely 1,080 horsepower each, possessed no effective turbo supercharging. Above 20,000 feet, these engines produced barely 60% of their rated power. The thin air at altitude starved them of oxygen, performance degraded catastrophically. One man managed to close on his target. Warrant Officer Sadamitsu Kimura positioned himself behind a B-29 designated Lima Dragon, its 12-man crew unaware of the danger closing from behind. Kimura's guns hammered fire into the bomber's fuselage. The B-29 erupted into flames and fell from the sky, with no survivors escaping the inferno. It was a lone Japanese success, but it came at devastating personal cost. Kimura had expended nearly all his ammunition in the attack. His engine was now dangerously overheated. He barely managed to coax his damaged fighter back to base, his hands shaking on the controls, knowing how close he had come to auguring in at altitude. Around him, other Japanese pilots had fired desperately at the silver bombers cutting through the sky. Most attacks achieved nothing. The B-29's defensive armament, controlled by sophisticated fire control systems far beyond anything Japan possessed, responded with punishing accuracy. Captain Teruhiko Kobayashi, one of the Imperial Army's most skilled fighter leaders from the 244th Sentai, later documented the bitter frustration in his unit's reports. American bombers operated at altitudes where Japanese fighters barely maintained level flight, let alone maneuvered effectively for combat. The advantage was so overwhelming that most pilots flying against them recognized the mathematics simply did not favor survival. The B-29's speed at altitude, approximately 350 miles per hour, precisely matched what Japanese interceptors could achieve in the thin air above 25,000 feet. Yet reaching bombing altitude consumed enormous amounts of fuel, left fighters carrying reduced ammunition, and pushed engines to temperatures where catastrophic failure threatened constantly. The secret to American superiority lay in engineering that Japan had explored, researched, and studied, but never successfully implemented at scale. General Electric's turbo supercharger Type B series represented a masterpiece of engineering. Each R3350 engine mounted two of these devices. Hot exhaust gases, captured in the supercharger's housing, spun turbine wheels that exceeded 20,000 revolutions per minute. The centrifugal forces they endured immense and relentless. These spinning turbines drove centrifugal compressors, forcing air into engine intake manifolds at pressures equivalent to sea level, regardless of altitude. The principle was elegant in its simplicity. Energy that would normally dissipate uselessly into the atmosphere instead performed crucial work by compressing intake air. This allowed engines to burn fuel efficiently even at altitudes where unassisted engines would simply suffocate. Each turbocharger added approximately 150 pounds per engine installation, yet delivered performance improvements equivalent to doubling the engine's displacement. Without turbochargers, the B-29 would have been merely another heavy bomber, vulnerable to interception and unable to use altitude as a defensive advantage. Japan had begun experimenting with turbo supercharging as early as 1941, when Nakajima Aircraft Company engineers examined captured technical documents and obtained sample units through secret routes before America's entry into the war. Japanese engineers recognized clearly the military advantage such technology provided. They understood it intellectually and strategically. Yet despite 3 years of intensive development, Japan never produced operational turbo-supercharged fighters in meaningful numbers. The reasons exposing the vast industrial chasm separating Japan from America. Turbo-superchargers demanded metallurgical expertise Japan simply did not possess. Turbine wheels operated in exhaust temperatures exceeding 1,500 degrees Fahrenheit, while spinning at velocities creating centrifugal stresses equivalent to thousands of pounds per square inch. A single metal imperfection, a microscopic flaw invisible to the human eye, caused catastrophic turbine failure. American manufacturers like General Electric possessed the metallurgical knowledge, precision forging equipment, and quality control systems to produce reliable turbines consistently. They had built the industrial foundation over decades. Japanese industry, stretched desperately thin by the demands of ongoing warfare on multiple fronts, could not match these exacting standards. Lieutenant Fumio Nihua, an engineering officer who evaluated captured B-29 components later in the war, documented findings that survived in Japanese archives. He examined a turbocharger that had been carefully removed from a crashed B-29 recovered in China. The experience humbled him. Turbine blades had been machined to tolerances measured in thousandths of an inch, balanced with such precision that units spun at maximum speed without even the slightest vibration. The high-temperature alloys used in turbine construction exceeded anything Japanese industry had ever produced. Even the bearings, designed to operate in extreme heat while maintaining precise alignment within fractions of a millimeter, represented manufacturing capabilities that Japan simply did not possess. More devastating still was the systematic nature of American production. General Electric's massive facility in Schenectady, New York, manufactured thousands of superchargers monthly, each one meeting exacting specifications verified by automated testing. Production lines incorporated sophisticated equipment that verified the performance of every single unit before it was installed aboard an aircraft. Defective components were identified and rejected before they could reach operational squadrons and endanger crews. By contrast, Japanese attempts at turbocharger production yielded perhaps dozens monthly, with reliability so poor that most failed after only a few operational hours aloft. The reliability gap was staggering. The difference between hundreds working per month and dozens failing rapidly meant that while America was building an abundance of these critical components, Japan was struggling to produce even enough to field a single squadron. By August 1944, Japanese intelligence compiled deeply disturbing reports about American bomber capabilities. Interrogation of captured B-29 crewmen, meticulous wreckage analysis from crashed bombers, and detailed pilot observations painted a picture of technological superiority that shocked military leaders at the highest levels. The B-29 was not simply a large bomber. It was an integrated flying weapon system incorporating innovations that Japan could not match and could not rapidly develop. Colonel Takashiro Hattori, an operations officer at Imperial General Headquarters, wrote in his diary that month about the implications of these raids. His words carried resignation and dread. American bombers operated with near-complete impunity at altitudes that Japanese fighters simply could not effectively reach. The few interceptors that managed to achieve engagement reported that even when scoring direct hits, the B-29's rugged construction absorbed damage that would destroy Japanese aircraft. Most alarming was the realization dawning on Japanese leadership that these raids represented only the beginning. American production capabilities suggested thousands of B-29s would eventually be deployed against Japan, each one beyond effective defensive reach of existing fighters. The mathematics of interception had turned catastrophically against Japan. A fighter climbing from ground level to 30,000 feet consumed perhaps 30 minutes and burned one-third of its fuel load just reaching altitude. At that height, fighter performance degraded dramatically. Guns, while deadly at close range, required pilots to close within a few hundred feet of targets, a maneuver made nearly impossible by the reduced aircraft performance and the B-29's sophisticated defensive fire control systems. Even successful interceptions often cost irreplaceable experienced pilots who died when fuel-depleted fighters, damaged from combat or engine strain, crashed attempting to return from extreme altitude. Major Makoto Ogawa, who eventually claimed 7 B-29 kills to become one of Japan's most successful Superfortress hunters, later described the overwhelming disadvantage that Japanese pilots faced. American bombers flew in a realm where Japanese aircraft barely functioned. Americans enjoyed pressurized cabins with heated compartments, allowing crews to operate effectively, while Japanese pilots endured temperatures 40 degrees below zero at high altitude, their fingers numb despite electrically heated flight suits that rarely worked properly. Oxygen systems frequently malfunctioned, leaving pilots hypoxic and dangerously disoriented. Gun barrels froze solid, Ammunition belts jammed in the brutal cold, and engines ran so rough with mechanical strain that pilots constantly feared flameouts and catastrophic failure. Japanese aircraft designers desperately sought solutions to this impossible problem. The Nakajima Ki-87 was developed specifically as a high-altitude B-29 interceptor, incorporating a turbo-supercharged Nakajima Hei 2119 engine intended to deliver effective performance above 30,000 feet. On paper, the design was impressive: service ceiling above 40,000 feet, heavy armament of 30mm and 20mm cannon, and speed sufficient to overtake B-29 formations. Only one prototype flew before the war's end in April 1945, and it demonstrated severe problems. The turbocharger, cobbled together from inadequate materials with insufficient testing and refinement, failed repeatedly during flight testing. Even when it functioned, performance remained inconsistent and unreliable. The project died not from any lack of engineering skill among Japan's finest aeronautical minds, but from a fundamental lack of industrial capacity to produce reliable turbochargers in any meaningful quantity. The Tachikawa Ki-94, another proposed high-altitude interceptor, never progressed beyond the mock-up stage. The Mitsubishi J-8M, a rocket-powered interceptor based on the German Me-163 Comet design, offered high-altitude capability without requiring turbochargers, but the dangerous liquid rocket fuel and extremely short endurance made it impractical for defending against sustained B-29 raids, where interception windows lasted mere minutes. Japan's finest aeronautical engineers understood precisely what was needed to counter the B-29 threat. They possessed the intellectual capability and the creative problem-solving skills. What they lacked was the industrial foundation, the manufacturing capacity, the metallurgical expertise, the quality control systems, the raw materials, to produce what their brilliant minds had conceived. American B-29 operations expanded relentlessly through the autumn of 1944. By November, the 21st Bomber Command began flying regular missions from Mariana bases on Saipan, Tinian, and Guam. These islands lay only 1,500 miles from Tokyo, well within the B-29's combat radius. Robert K. Morgan's mission on November 24th sent 111 Superfortresses against the Musashino aircraft engine plant in Tokyo's industrial district. Weather conditions and powerful jet stream winds limited bombing results that day, but the psychological impact on Japan was profound and unmistakable. American bombers now struck the homeland almost daily, approaching with seeming impunity, and Japanese defenses proved increasingly ineffective at stopping them. Sergeant Shoichi Suzuki, an anti-aircraft gunner stationed near Tokyo, kept a diary documenting the growing despair spreading among those tasked with defending the capital. Initially, his unit had engaged B-29 formations with genuine confidence, their 75mm guns firing shells to altitudes around 25,000 feet. But American bombers often flew higher, remaining beyond effective gun range, or approached at angles giving gunners insufficient time to track and aim. More frustrating than anything was the grim reality that even direct hits rarely brought down B-29s. The bomber's structure, built with redundant systems and armored in critical areas, withstood damage that would have obliterated Japanese aircraft. Suzuki recorded watching crippled B-29s, trailing smoke with engines shut down, nevertheless continuing toward their targets and often returning safely to base on remaining engines. It seemed almost supernatural. Japanese efforts to improve air defenses focused desperately on fighter performance modifications. The Kawasaki Ki-61 Hien, powered by a liquid-cooled Hei 40 engine, could reach altitudes around 32,000 feet, higher than most Japanese fighters. But climb rate was insufficient, and engine reliability so poor that many Ki-61s were grounded awaiting spare parts that simply were not available. The Nakajima Ki-84 Hayate, introduced in 1944, represented Japan's best mass-produced fighter. It featured the Nakajima Homar engine, a complex radial design delivering good performance at altitude when properly maintained and operated by skilled pilots. However, the Homar's intricate construction made it maintenance-intensive, and quality control problems meant many engines failed prematurely despite the best efforts of Japanese mechanics. The Ki-84's theoretical performance was genuinely impressive. Maximum speed around 400 miles per hour at 20,000 feet, service ceiling near 35,000 feet, and heavy armament of 20mm and 30mm cannon. In practice, few Ki-84s achieved these specifications. Poor quality fuel damaged engines. Crude lubricants broke down in low temperatures. Manufacturing defects caused frequent failures, even in newer aircraft. American pilots who test flew captured Ki-84s after the war praised their handling and performance, noting the aircraft matched or exceeded American fighters in several respects. But they also observed that these captured examples had been selected for exceptional condition, maintained by the most skilled Japanese mechanics, using hoarded supplies of high-quality materials. The average operational Ki-84, performing regular combat missions, achieved performance far below design specifications. Even when Japanese fighters managed to reach B-29 operating altitudes, they faced the bomber's sophisticated defensive armament. Each Superfortress mounted 10 50-caliber machine guns arranged in remote-controlled turrets, positioned strategically around the fuselage. A central fire control system allowed coordinated engagement, enabling gunners to concentrate multiple turrets on single targets with devastating effect. The system incorporated computing sites that automatically calculated lead and deflection, significantly improving hit probability. Japanese pilots quickly learned through bitter experience that approaching within effective gun range of a B-29 formation meant flying straight into coordinated barrages. Few pilots survived. The psychological impact on Japanese pilots was devastating, pushing some to despair. The Japanese military had been taught to believe in the absolute superiority of their aviation force, in the irresistible power of the Bushido spirit over mere material resources. But the reality of facing B-29 Superfortresses shattered those beliefs with brutal finality. Captain Yasuhiko Kuroe, a seasoned fighter pilot flying with the 300th Air Group, penned words in a wartime letter that would surface after the conflict ended. Fighting B-29s, he wrote, was like attacking a moving fortress in the sky. These American bombers could absorb punishment that would obliterate a dozen Japanese fighters. Their crews sat protected behind layers of armor and backup systems, while Japanese pilots flew exposed in unarmored cockpits, their fuel tanks dangerously vulnerable, their bodies shielded by almost nothing. When December 1944 arrived, it brought the first major daylight assault on Tokyo itself. 86 B-29s descended on the Musashino manufacturing plant. Japanese air defenses managed to bring down or damage some bombers, but the price was staggering. The 204th Sentai, under Captain Kobayashi's command, claimed 6 B-29s destroyed through desperate ramming tactics, yet lost multiple irreplaceable veteran pilots in those attempts. As the campaign intensified, ramming became standard practice. Japanese pilots understood that conventional attacks frequently failed to cripple such massive aircraft. They would steer their fighters directly at B-29 wing surfaces or tail sections, seeking to shear away critical control surfaces, then hope to escape by parachute before collision. Few made it out alive. This approach was almost certain death. American bomber crews felt a strange mixture of emotions watching these attacks: respect for the fearless sacrifice, horror at the waste of human lives. Technical Sergeant John McLaughlin served as a gunner aboard the City of Los Angeles. Years later, he recounted what he witnessed one afternoon as a Japanese fighter bore straight toward the B-29, flying just beyond his own position. The fighter struck the bomber's tail assembly with tremendous force, shearing off the entire vertical stabilizer in a shower of metal fragments. Both aircraft immediately entered uncontrolled spins, plummeting toward the earth below. McLaughlin scanned the sky desperately for parachutes. He saw none. He would eventually learn that the B-29 crew, 10 men, perished in that fall from the sky. The Japanese pilot's identity was never recorded, one among thousands of young men who died defending the homeland against an enemy they could never defeat. By early 1945, Japan's air defenses were collapsing from exhaustion and attrition. Fuel shortages meant many fighters never left the ground. The veterans who had once led Japan's air forces were gone, killed in staggering numbers over months of combat. Their replacements were teenagers with barely enough training to keep an aircraft aloft, facing experienced American bomber crews and their escorts. When American P-51 Mustang fighters began operating from captured Iwo Jima in March 1945, the situation became hopeless. Japanese interceptors climbing slowly toward high altitude became simple targets for Mustangs that could climb faster, fly higher, and outfight any Japanese aircraft in existence. March 9th to the morning of March 10, 1945, brought Japan's worst disaster. General Curtis LeMay, commanding the 21st Bomber Command, made a radical decision. Forget the high-altitude precision bombing tactics. Instead, 334 B-29s would strike Tokyo at night from around 7,000 feet, carrying incendiary bombs designed to ignite massive fires. The decision sparked controversy. Lower altitude meant heavier anti-aircraft fire, greater vulnerability. Yet LeMay calculated shrewdly that Japanese night defenses were weak, and the reduced altitude meant engines ran cooler, eliminating turbocharger strain and engine overheating problems that plagued high-altitude operations. Each bomber could carry substantially more tonnage. The results staggered even LeMay's expectations. In just 3 hours, American bombers dropped nearly 2,000 tons of incendiaries across Tokyo's densely packed residential districts. Firestorms erupted, creating ferocious winds that sucked oxygen from underground shelters and generated temperatures exceeding 1,800 degrees Fahrenheit. Around 100,000 people perished, more deaths than either atomic bomb would eventually cause. 16 square miles of the city transformed into ash. Only 14 B-29s failed to return, a remarkably low loss rate considering the raid's intensity. Yet even this devastating campaign depended fundamentally on turbo-supercharger technology. Without the ability to operate at altitude, to climb above weather systems, to cruise beyond the effective reach of fighter interception, the entire strategic bombing strategy would have been unsustainable. Missions from China across vast distances to targets in Kyushu demanded high-altitude efficiency. Daylight precision attacks on aircraft factories and oil refineries required the protection that altitude provided. Even the low-level firebombing raids became possible only because American air superiority had been established through earlier high-altitude operations that had decimated Japanese fighter production. Japanese engineers who examined salvaged B-29 components after the war expressed grudging admiration tinged with despair. Turbo-superchargers represented everything their own industry lacked: precision manufacturing, sophisticated materials science, rigorous quality control, the capacity to mass-produce thousands of these intricate units every single month. A single B-29 carried 8 turbo-superchargers. American factories produced more than 200 B-29s monthly by 1945. That meant 1,600 turbo-superchargers monthly just for new aircraft, plus thousands more for maintenance and replacement. General Electric's production facilities achieved rates that Japan could never have matched, even if it had devoted its entire aircraft engine industry exclusively to turbo-supercharger manufacturing. The broader implications became unmistakable to perceptive Japanese observers. If America could manufacture turbo-superchargers at such staggering volumes, what else could it produce? The answer manifested as waves of B-29s darkening Japanese skies almost daily by summer 1945, as P-51 Mustangs that destroyed Japanese fighters with ease, as naval blockades that cut Japan from every resource, as atomic bombs descending on Hiroshima and Nagasaki. First Lieutenant Toshio Ota, a technical intelligence officer who survived the war, later reflected that studying captured American aviation equipment filled him and his colleagues with despair. Every system, every component, demonstrated manufacturing sophistication and engineering excellence beyond anything Japan's industry could achieve. Turbo-superchargers affected him particularly, conceptually straightforward, yet demanding precision that Japan's war-damaged industrial base could no longer meet. Even had Japan somehow obtained turbo-supercharger designs in 1941, he concluded, the nation lacked the manufacturing infrastructure to produce them in useful quantities. The human toll of this technological gap proved catastrophic. Japan's pilot training programs, once rigorous and producing exceptional aviators, had disintegrated by 1945. Fuel rationing meant student pilots received perhaps 50 hours of flight training compared to the 200 to 300 hours American pilots received. These inadequately trained young men flew obsolete aircraft against opponents who possessed every conceivable advantage. In July 1945, during a massive aerial battle over the inland sea, Japanese fighters attacked a formation containing over 100 B-29s. American records indicate that perhaps 2 bombers sustained damage, while Japanese forces lost 23 fighters, destroyed with barely any meaningful harm inflicted on the bomber formation. The cumulative B-29 campaign ultimately dropped 147,000 tons of ordnance across Japanese targets, obliterated 40% of the urban and industrial areas in 66 cities, and killed approximately 330,000 civilians. Japanese war production, already declining steeply, collapsed entirely by summer 1945. Transportation networks lay in ruins, making it impossible to move resources even when they existed. Factory workers abandoned their posts, fleeing burning cities. The government lost command over economic planning as surviving industries scattered to rural regions or dispersed operations. Major General Aris Sui Seizo, chief of Japanese military intelligence, admitted after the war that by June 1945, his analysts recognized that defeat had become mathematically inevitable. American air dominance was absolute and unchallenged. The B-29 campaign had systematically destroyed Japan's capacity to continue fighting. Yet the government, bound by military codes of honor that forbade surrender, persisted in the struggle until atomic weapons provided the justification needed for capitulation. The atomic bombings of Hiroshima on August 6 and Nagasaki on August 9, 1945, brought the war to its end. Those atomic bombs were delivered by B-29s, aircraft whose capacity to reach Japanese targets and return safely rested fundamentally on turbo-supercharger technology. The Enola Gay, maintaining an altitude of 31,000 feet above Hiroshima, operated at that height because 8 General Electric turbo-superchargers kept the engines producing full power in the thin stratospheric air, even with Japanese defenses essentially eliminated by war's end. Altitude capability provided by turbo-superchargers offered crucial protection from remaining anti-aircraft fire and allowed crews to escape the atomic blast effects. Post-war conversations with Japanese fighter pilots revealed a consistent pattern: admiration blended with frustration. They respected American engineering and understood clearly that no amount of pilot skill could overcome technological inferiority. Lieutenant Isamu Sasaki, who survived the war having destroyed 3 B-29s, among the highest tallies achieved by any Japanese pilot, reflected years later that his successes came only when circumstances aligned perfectly. A surprise attack from above, with the sun at his back, against bombers separated from their formations. Against bombers flying in formation at altitude with vigilant crews, even the finest Japanese pilots rarely succeeded. Many nations had pursued high-altitude aviation capability before World War II. Germany developed turbo-superchargers but never successfully deployed them operationally, preferring instead mechanical superchargers, which operated more simply but proved less efficient at extreme altitudes. Britain relied primarily on sophisticated multi-stage mechanical superchargers that delivered respectable high-altitude performance without turbocharging complexity. America alone made turbo-supercharging standard equipment on its heavy bombers, accepting the additional complexity, cost, and maintenance burden in exchange for previously unattainable high-altitude performance. This choice reflected American industrial confidence. Turbo-superchargers demanded precision manufacturing, regular maintenance performed by skilled mechanics, and steady supplies of replacement components. America possessed the industrial infrastructure to support these requirements in abundance. Japan possessed none of these advantages. Even if Japanese engineers had designed perfect turbo-superchargers in 1941, the nation lacked the manufacturing base to produce them in quantity, the maintenance organization to sustain them, and the supply system to furnish necessary spare parts and replacement units. The post-war U.S. Strategic Bombing Survey concluded that the B-29 campaign proved decisively effective in destroying Japan's capacity to wage war. While survey authors debated whether Japan would have surrendered without atomic bombs or planned invasion, they unanimously agreed that by August 1945, American air dominance was complete, and Japanese defenses lay in ruins. The B-29's technological advantages, particularly the high-altitude capability enabled by turbo-superchargers, made this outcome inevitable once sufficient bombers became available in quantity. Japanese records seized after the war revealed how thoroughly B-29 raids dominated military planning from late 1944 onward. Imperial General Headquarters poured enormous resources into air defense, pulling fighter squadrons from other theaters, constructing thousands of anti-aircraft positions, and training tens of thousands of troops for airfield protection. Every effort proved futile against bombers operating beyond the effective range of any defensive weapon Japan possessed. The final B-29 mission against Japan flew on August 14, 1945, the day before surrender was announced. More than 300 Superfortresses attacked targets near Tokyo, encountering absolutely no opposition. Japanese fighters sat on the ground, preserving fuel for the anticipated American invasion that would never materialize. B-29 crews returned to their bases in the Mariana Islands, unaware that the war was effectively concluded. Their mission accomplished through the cumulative destruction of hundreds of raids that Japan could never stop or significantly counter. In the decades following the war, aviation historians and aeronautical engineers conducted extensive analyses of B-29 technological advantages. Professional consensus emerged with clarity. Turbo-supercharging provided the fundamental capability that made strategic bombing of Japan possible from remote bases. Without this technology, B-29s would have been restricted to operations around 20,000 feet, well within the effective range of Japanese fighters and anti-aircraft artillery. Losses would have escalated beyond sustainability. The entire strategic concept of bombing Japan from Mariana bases would have been impractical and unworkable. The lessons Japanese engineers absorbed from examining American aviation technology influenced post-war Japanese industrial development significantly. The emphasis on precision manufacturing, rigorous quality control, and systematic engineering that characterized American turbo-supercharger production became defining characteristics of Japan's post-war economic transformation. Former aviation engineers transitioned into civilian industries, bringing with them hard-earned understanding of advanced manufacturing techniques. The Boeing B-29 Superfortress flew its final combat mission in 1954 during the Korean War. By then, jet-powered bombers were replacing propeller-driven aircraft, and turbo-supercharging for piston engines had become obsolete technology. Yet the B-29's legacy endured powerfully. It demonstrated that technological superiority could overcome numerical disadvantage, that industrial capacity mattered as much as individual courage, and that air power alone could destroy a nation's capacity to wage war. Today, only 2 B-29s remain capable of flight, preserved and maintained by dedicated organizations, ensuring that future generations can witness these historic aircraft in person. When these bombers fly at air shows, their Pratt & Whitney engines produce that distinctive, deep-throated roar that stirs memories. Few spectators realize that hidden within the engine nacelles are turbo-superchargers, survivors of technology that helped bring history's most destructive war to conclusion. Those components, spinning at thousands of revolutions per minute as B-29s climb toward altitude, still perform the function they were engineered for 8 decades ago, compressing air to maintain full engine power in the thin atmosphere of extreme altitude. The story of Japanese forces confronting B-29 superfortresses ultimately reveals how industrial capability and technological innovation determined the outcomes of modern warfare. The turbo-superchargers that permitted B-29s to operate at 30,000 feet, the industrial production systems generating thousands of these complex components monthly, the training programs preparing crews to operate them effectively, the supply networks maintaining them in functioning condition. These represented the true weapons of the strategic bombing campaign. The B-29's technological superiority did not guarantee American victory from the beginning of the war. But once American industry mobilized fully, once B-29 production reached maximum scale, Once the Mariana air bases became operational, Japan's defeat became absolutely inevitable. No amount of pilot skill, no level of sacrifice could overcome the material and technological advantages embodied in those silver bombers droning overhead at altitudes where Japanese fighters struggled desperately for air. When B-29 crews operated at 30,000 feet above Japan, their turbo superchargers spinning silently within engine nacelles, maintaining sea-level engine power in the stratospheric void, they carried more than bombs and ammunition. They carried proof that industrial might had become the decisive factor in modern warfare, and America possessed that capability in quantities no adversary could possibly match. Japan never anticipated this reality. Once the silver bombers filled the skies over the home islands, operating beyond the reach of any defensive system, there existed nothing Japan could do to prevent them or turn back the tide they represented.